Welcome to the final part of VCAA Math Method 2021 exam paper series. In this video, we will solve exam paper 2, section B, question 5, which consists of 8 parts. They deal with circular function and transform the circular function related problems. Statistically, this question was done poorly, which we will demonstrate and explain in detail through this video.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA exam paper series. This is section B of 2021 exam 2 paper. There are total 5 extended response questions in section B. In this video, I will present you the 5th extended response question. Question 5 shows the function f of x equals sine x over 2 plus cos 2x. Its domain is a real number, and part of the graph is shown on the screen. Based on this, there are 7 parts in question 5. Part A is to find the period of f of x, and part B is to find the minimum value of f of x. Part C is to find the smallest possible value of h, for which f of h minus x equals f of x. Now the function f of x is transformed to g sub a of x, which equals sine x over a plus cos ax, where a is a positive integer. Accordingly, part D of this question is to find the value of a such that g sub a of x equals f of x for all x. Part E of this question has 2 requirements. The first requirement of part E is to find an entire derivative of g sub a of x in terms of a. The second requirement of part E is to use an integral to show that the area bounded by g sub a of x and the x-axis over the closed interval from 0 to 2a pi is equal above and below the x-axis for all values of a. Part F is to explain the maximum value of g sub a of x cannot be greater than 2 for all values of a, and why the minimum value of g sub a of x cannot be less than negative 2 for all values of a. Part G is to find the greatest possible minimum value of g sub a of x. Now let's come back to solve part A of this question. According to our observation on the given graph, we find the distance between 2 maximum points is 4 pi. So the period of this function f of x is 4 pi. In part B of this question, since the minimum value cannot be directly obtained by visual observation, we need to find stationary points so that the minimum value can be found. Hence, f prime of x equals cos x over 2 divided by 2 minus 2 sine 2x. Set it to 0 and solve the equation using CAS calculator. Then we find that when x equals negative 4.62743 or 7.93894, f of x reaches its minimum, which is negative 1.722. Part C of this question is to find the smallest possible value of h, for which f of h minus x equals f of x. In order to find the possible value of h, based on the f of x graph, we do the following simple transformation on the maximum point, pi 2, which is selected for easy to observe and trace down. First, we reflect the point in y-axis. It becomes negative pi 2. The next step is to translate 2 pi units in positive x-axis direction. so the coordinates of the point is translated to pi 2. Hence, f of negative x minus 2 pi, or in parentheses, equals f of 2 pi minus x, which equals f of x. So h equals 2 pi. Part D is to state the value of a so that g sub a of x equals f of x for all x. Since g sub a of x equals sine x over a plus cos ax, and it equals f of x for all x, it is quite obvious only when a equals 2. G sub a of x is exactly same as f of x. Hence, we find a equals 2. The first requirement of part E is to find an antiderivative of g sub a of x in terms of a. So the integral of sine x over a dx plus the integral of cos ax dx, which equals negative a cos x over a plus sine ax divided by a. The second requirement of part E is to show the area bounded by g sub a of x and the x-axis over the closed interval from 0 to 2a pi is equal above and below the x-axis for all values of a. What we do is to integrate g sub a of x over the interval and see if it is equal to 0. Hence, the integral from 0 to 2a pi of g sub a of x dx equals negative a cos x over a plus sine ax divided by a, or in parentheses valued from 0 to 2a pi, which equals negative a plus 0 plus a minus 0, which is 0. So the bounded area above and below the x-axis are equal. Part F is to show why the maximum value of g sub a of x cannot be greater than 2, and at the same time why g sub a of x cannot be less than negative 2 for all values of a. Since both of the modulus of sine x over a and the modulus of cos ax are less than or equal to 1, g sub a of x is greater than or equal to negative 2 but is less than or equal to 2. Therefore, the maximum value of g sub a of x cannot be greater than 2, and at the same time it cannot be less than negative 2 for all values of a. Part G of this question is to find the greatest possible minimum value of g sub a of x. To find its greatest possible minimum value, we need to plot the function g sub a of x, which equals sine x over a plus cos ax, where a is a parameter. We vary the parameter a from 1 to 4 and plot these graphs as shown on the screen to make an overall comparison. As it can be seen, when a increases, the minimum value of g sub a of x decreases. Hence, we may roughly conclude that when a equals 1, g sub a of x has its greatest minimum value. To find this value, we set a equals 1 and then differentiate g sub 1 of x with respect to x, which equals cos x minus sine x. After setting it to 0, we obtain that tangent x equals 1. Therefore, when a equals 1, the stationary points of g sub 1 of x are at x equals n pi plus pi over 4, where n is an arbitrary integer. However, when a equals 1 and x equals 2n pi plus 5 pi over 4, g sub a of x reaches its greatest minimum value, which is written to g sub 1 of 2n pi plus 5 pi over 4, which equals sine 2n pi plus 5 pi over 4 plus cos 2n pi plus 5 pi over 4, which equals negative square root of 2, where n is an arbitrary integer. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.